In the previous video, when we looked at the structure of a circuit, we looked at how the power supply in the form of batteries supplies electrons for the creation of a current that moves around from the anode to the cathode, and how the movement of electrons can be used to supply the energy that allows our load, in this case the light bulb, in order to function. Now, this is a fairly simple circuit, but as circuits get more complicated, if we were to actually draw out the structure of more complicated circuits, we can see how this would become very cumbersome. So in this video, we're going to take a look at a simplified notation system that we can use to represent circuits, which is, not surprisingly, what we call circuit notation. So circuit notation is a shorthanded system that is used by electricians and electrical engineers to represent circuits in a simplified form, but still understand all of the basics about how a circuit works. For example, where and how many power supplies do we need? What is the direction of electron flow? What is the load in the circuit? And how many different loads we have. So what we're going to do is we're going to use the shorthanded symbols that we see here on the right to construct the circuit from the previous video using circuit notation. So in this circuit notation, we can see that a single battery cell is represented like this. So we can draw what a battery looks like here. So in the previous video, we saw that the electron flow is moving in a clockwise direction, which means that this end here is our anode. This is the positive side. So in our circuit notation, our battery is going to be positioned like this so that we can see the anode of the battery like this. However, our circuit in the previous video actually had 3 different battery cells, so we can simply draw out 3 different battery cells to reflect that here. So here, what I've simply done is I've used the shorthand for a battery cell, and I've drawn 3 of them linked in a row like this. Now we can draw connecting wires the same way that they are used, and we can see at this point in the bend in our circuit, we have this digital transistor that we have here. So this would be an example of a resistor, because when the electrical current passes through this transistor, it's going to slow down the current. So we can see on our shorthand for circuit notation, if we want to represent a resistor, we can draw a zigzag line like this, showing that there is going to be some sort of resistor here that is going to slow down the current. Then eventually we're going to get to our load, which is a light bulb, and here's where my limitations as an artist come in, but I'm going to do my best here and draw what the light bulb is here. Now, some forms of circuit notation will have a light bulb surrounded by a circle like this, so where this wire inside of the light bulb represents the filament. This is the part that actually glows. And then after the light bulb, if we check our circuit on the previous page, we see that it goes through a switch or a circuit breaker here. So we can see that the way that a switch works is relatively simple. So we can draw the switch like this. And if we were to represent the switch like this, this is what the switch looks like in the off position, because here we can see that our circuit is broken. But if we actually want to turn on the light, if we want to put the circuit breaker in the on position, we can simply redraw the switch like this, where the circuit is closed, meaning that the electron flow can move from the anode all the way to the cathode, because our circuit is complete. So once again, this circuit here that we've drawn using circuit notation is exactly the same as this circuit here, because we have all of the batteries that we use as our power supply here, and we can see that the positive end of the battery, the anode, is at this end, meaning that our electrons will flow this way through the resistor where the current slows down and through this light bulb, which is our load in the case of this circuit. And because our circuit breaker is in the on position, the electrons can keep flowing this way until they end up back at the cathode at the negative end of the battery. As we go on in the portion of the electricity units concerned with circuits, we will explore the different symbols that we did not use in this particular diagram, but for now, we can see that circuit notation is not difficult to understand because each clearly represents a different component of circuits that we looked at in the previous video. In the next video, we're going to see how we can use circuit diagrams in order to do some fairly simple calculations regarding the voltage, current, and resistance of electrical circuits.